This is question number 8. Figure below shows a shaft rotate at 2000 rpm. An oil with viscosity of mu equals 0.5 Pascal second fill the 0.2 millimeter gap between rotating shaft and stationary housing. So determine the total power required to overcome the viscous resistance. So in this situation, you will see that we have a rotating device like this one. So we have here, we have the rotating device is here, and then it's straight, and then it has a cone here. Okay, so means that we need to calculate part by part. So at top bottom here, we will calculate according to rotating this. So at the side here, so we will calculate as rotating cylinder, and then at this inclined area, so we need to calculate as rotating cone. So means that you need to calculate 3 times, and then we need to calculate the power to overcome the resistance. So how to calculate the power? Okay, the equation of power is actually power is equal tau omega. So power is equal torque times omega. So times rotational speed, which is the omega. Okay, so means that we calculate the torque, and then we multiply with the omega, then you could get the total power here. So to solve this problem, so we need to calculate the omega here. So if rotational speed is 200 rpm, so we could convert it into 209.44 radian per second according to this equation. So the common equation that you could remember is U equal to R omega, it is equal to pi dN over 60. Okay, so and then we know from the question the mu is 0.5 Pascal per second. So this is the gap. Please make sure that you write in SI unit. So this is the diameter, and this is the radius of the device. Okay, now we calculate the rotating disc first. So this is the power for this. So this is the torque. Okay, and then this is the omega. So and then according to our previous tutorial, we could calculate the torque by using this equation, and then we multiply with the torque. So if we substitute the value, so this is the value, and it is equal to 0.108 watt. And then for cylinder, we need to calculate the torque for cylinder times with the omega. So and this is the equation for the torque of rotating cylinder. So this is the omega. So we could substitute the equation, substitute the value. So we get it is equal to 25.84 watt. And finally, we calculate the cone here. So we could have this is the torque for the cone. So and then this is the omega. So we substitute the value. So we get it is equal to 0.215 watt. So and then we could get the total power by adding all the power from the cylinder, from the disc, from the cylinder, and from the cone, and it is equal to 26.163 watt.